You guys, today, our dino of the day is, well, by all accounts, the most heavily armored dinosaur of all time. If you have a guess, you can drop that in the comments. It's also my brother's, Max, who may show up at some point. He's also my brother's favorite dinosaur. If you have any guesses, Christine, do we see any guesses as to what dinosaur people think this is? Most heavily armored dino of all time, and it was around right at the end of the Cretaceous when non-avian dinosaurs went extinct. We're going to talk about extinction today. Any guesses? We got any guesses?
I don't see any guesses in the chat yet. Oh, I see Cecilia has her hand up. Cecilia, I'm about to unmute you. Who is the dino of the day? Try again, Cecilia. Oh, no.
I think it's the Ankylosaurus.
Yeah, Cecilia.
Wait, that's not how this works. Hold on. Let me share the screen.
I saw it.
Did you see the Ankylosaur?
Yeah, there she is.
Nice.
Well done, Cecilia.
It's funny that I can't quite see. There we go. Hold on. Let me do this. This will make it way easier for me. 1 second.
Oh,
yeah.
Joan got it in the chat too. Well done, Joan.
Yeah, so you guys, this is an Ankylosaur. This is actually like a model mock-up for Jurassic World. Yeah, who's writing on it? I don't know how that's happening, but great. So this is an Ankylosaur. So these guys are about 25 feet long, so pretty large. Like when I first learned about Ankylosaurs, I thought they're awesome. Obviously, it looks like a walking tank. It's got the spikes on the top of its head, these horns coming out the side, incredibly heavily armored. We have osteoderms, which are chunks of bone that are embedded in the skin coming out here for protection. Most notably, at the end, we have 2 bowling ball size tail clubs. We think this thing uses defense against dinosaurs like T-Rex. Here's another image, which, oh, wow, you really have to have them all open. Give me 1 hot second here.
Mm-hmm. In the meantime, Dustin, I see Mary
please.
Beth has a hand up. So Mary Beth, I'm about to unmute you and have you go ahead with your question. Go ahead, Mary Beth.
My chat was disabled and I don't know.
Oh, I'll try to fix that for you.
All gravy. Can you guys see this, the Ankylosaur now with the scale, the person for scale?
I can see it.
Yeah.
Oh, I can see it with the elephant for scale.
Yeah, so that's what I meant. I thought this guy was a lot smaller originally, but they're actually relatively big, right? You can see the size comparison next to an elephant right here. Pretty scary guy, and they use, again, those giant tail clubs for defense, right? So let's say you got a T-Rex or something trying to hunt him. If you've seen the scene in Jurassic World, actually, I think they did that pretty well, where the Ankylosaur faced away from the T-Rex, kind of swung that tail. Let me show you what those osteoderms at the end of the tail look like. Where did that picture go? I'm losing all my images today, guys. I'm sorry. There we go. Close this one more time. Thank you guys for being here on Insta. All chat is disabled on Zoom. Can you check into that, Christina?
Yeah, I am.
So I'm actually curious, of you guys, has anyone that is watching right now actually seen this fossil at the American Museum of Natural History? Does anyone, a couple of you guys have? Cool. So this is the tail club from an Ankylosaur, and you can see on either side of the tail, those things are a little bit larger and a little bit longer, yes, than a bowling ball, and they're solid bone, and they'd be able to whip those with enough force to break bone like a T-Rex leg. That sounds painful. This is also a great opportunity, though, for us, while we are together today, talking about extinction. If you guys have a pen or paper or crayons with you, I'm going to challenge you guys to try to draw your very own Ankylosaur, right? And so just as a little piece of reference, I want to show you guys this picture that my brother, who is an artist, decided he was going to try to mock up last night in just a few minutes. So I'm not looking for anything too crazy. I like this one, though. It's a pretty cute little drawing. Not completely finished yet, but I want to see what your Ankylosaurs look like. So as we were talking today, make a sketch, make a drawing, whatever you want to do. And at the end, Christina's going to help me pick some very awesome, special-looking Ankylosaurs. And again, you do not have to be perfectly scientifically or anatomically accurate. I am not a very good artist. It would probably look like a stick figure with 2 bowling balls at the end. So do your best. All we can ask for is trying very hard. I also want to give a shout out to Miles and Sam, my nephews, watching at home, Let's go. I want to see your drawings because you guys are great artists as well. All right. Before we get into Extinction Day, I also want to mention and bring this up to the front of the screen here. You guys, I don't know if you know this yet, but we have a bingo card. You guys should be able to see the bingo card now. Every single day, we're going to have a different bingo card. Same squares, different order. I want you guys to try to figure out or try to get bingo 5 across. Thank you to Grace Astrove and Kelly Reedy for putting this together and roasting me pretty mercilessly. All right, here we go. So that's the bingo card. So Christina,
Hi.
correct me if I'm wrong, but I feel like the first day we talked a little bit about T-Rex. The second day we talked about how you identify a dinosaur from a not dinosaur. What did we talk about yesterday though? I'm forgetting what was yesterday.
Yesterday was fossilization.
Yesterday was fossilization. So we figured out how you tell a dinosaur from a dinosaur. We did fossilization yesterday. We now know, because we don't see them walking down the street, T-Rex and Kylosaur is no longer around, how and why did they go extinct? Today, we are talking all about extinction. So, Christina, you are the middle school science teacher, so you have the chops, and you're a geologist, so you know about this stuff. So first and foremost, before we even really get into it, what is extinction? And what is the difference between just something going extinct and a mass extinction?
So extinct means there aren't any, not even one living member of that species left.
Okay.
And the difference between one species going extinct and a whole mass extinction is there are thousands and thousands, maybe even millions of species that go extinct in around the same time during a mass extinction event.
So lots and lots of things. Also, someone the other day was like, "Oh, I heard this animal went extinct in this area." Like something you can no longer be in an area and in one area of the world, right? But that doesn't mean the animal itself is extinct, right? Extinct means that animal is no longer anywhere on Earth, right? So you never say like, "Oh, this animal is extinct in North America." Maybe it doesn't live there anymore, or they're no more existing in North America, but the animal itself is not extinct unless there are none at all around anywhere anymore.
Yeah.
Okay. Yeah. All right.
Yeah, as far as I understand, yeah.
Yeah. And so mass extinction means lots go extinct all at once. So as far as I know, there have been more than one mass extinctions that have happened over the course of Earth's history. Christina, how many generally are considered as like mass extinctions?
There have been 5 mass extinction events over the course of Earth's history.
5.
Yeah.
So the dinosaur extinction is only one of 5.
Yes. So it's the most famous one, and it's the flashiest one because obviously we're all here because we love dinos.
Mm-hmm.
And it involves space travel too. So like thinking about an asteroid hitting planet Earth, but that's not the only way that tons and tons of things can go extinct at the same time. So
there have been 5 mass extinctions. Do you want to tell us about like maybe one of your favorites and like what happened? Like what we know about?
Yeah, so I'm gonna give a shout out to an underrated mass extinction event. It's the end Ordovician. Everybody knows. So this is about,
like how long ago are we talking?
445 million years ago.
Okay, so about 200 million years before dinosaurs even showed up on the scene.
Before they even existed.
Okay.
So there's a lot of marine life at this point in time that went extinct over the course of about 3 million years. Because the climate got way colder and then suddenly way warmer. So a bunch of stuff went extinct, and then the stuff that adapted to a really cold environment then went extinct after the climate warmed right up again. Yeah.
Okay. Now that's not the Permian extinction though, because that's right.
Yeah, that one's a little later.
So I keep on hearing people mentioning the Permian extinction because I think that's the biggest mass extinction, and by biggest we mean the largest percentage of life went extinct in that extinction. So do we know approximately how much?
How much stuff went extinct?
Yeah, so in the Permian, which is the biggest mass extinction, what percentage of life went extinct in that mass extinction?
About 95% of species went extinct.
So 95% of all living things on Earth went extinct in the Permian extinction.
Yeah.
Wow. That is, and when exactly or generally was the Permian extinction?
About 250 million years ago.
200. Okay, so that really set the stage for the dinosaurs being able to start to take over, right? Because dinosaurs existed about, right around that time we started seeing dinosaurs on the scene, which is pretty cool. So, I mean, that's the way extinctions and life on Earth works, right? You clear out an ecological or environmental niche, life is going to find a way to live in that new niche and evolve and figure out all the different little ways it can survive and the different types of life it can survive in different areas. So it's pretty cool. Pretty cool. I mean, not fun for the animals that went extinct, but extinction in general is a pretty cool, like almost reset button on life. Ooh, great question I just saw from random kids. So Christina, when we say 95% of all living things, are we talking plants, or should I be saying 95% of all animals?
The numbers for this are about animals.
Okay.
But you can assume that all living things in a mass extinction event like that would react similarly, right?
Okay.
So we lost a lot of plant species as well, but the numbers I'm giving are for animals.
Okay. Yeah, megafauna always wins out. We don't talk about animals before. Not that there's anything wrong with plants, but it's just more fun to talk about giant animals for sure. All right, so we got 5 total. What?
Sorry. No, I just see a lot of questions in the chat. So I'm going to go back through these mass extinction questions that were coming up while I was on my soapbox about mass extinction.
Okay.
And make sure that we address them as we go on. I just wanted to tell people I do see these questions coming in.
Okay.
I'll get to them.
Cool.
Go ahead.
Reminder of the bingo squares, because I just said one of them by accident. I think that's how they work though. All right. Cheers to everyone. It's Monday. It's time to talk about dinosaur extinction. Again, I only drink out of wine glasses because I don't know if you know this, Christina, but I am the classiest person that you're friends with.
Oh, congratulations.
Yeah. Anyway. All right, let's do this. Dinosaur extinction. I don't know if you guys know this, and I'm sorry if this makes anyone cry, but most dinosaurs are no longer with us.
That is tough news.
Single tear. Yeah, so when we talk about dinosaur extinction, we're talking about a mass extinction event that happened about 65.5 million years ago. It spelled the end of all non-avian dinosaurs. We'll come back to that in a second. Now, there's obviously, and I'm sure many of you know, a lot of debate as to what exactly caused this mass extinction, what caused the death of the non-avian dinosaurs. And we're not exactly sure, but we've got some pretty good evidence to lean one way or the other as to what exactly, what combination of things led to this mass extinction. Like Christina mentioned, just like many mass extinctions before, climates all over the earth were changing, sea levels were changing. The thing that kind of conflates this particular extinction is the fact there was a lot of volcanic activity happening. Not only all over the world, but specifically in an area called the Deccan Traps in India. And so it's not like the volcanoes are erupting and then every dinosaur is getting hit on the head by lava. When you have volcanic eruptions, you're releasing lots and lots of noxious gases up into the air. If you're releasing tons and tons of gases into the air, that fills the atmosphere and it's going to change the composition of the air all over the world. So that may have also contributed. But it was probably the asteroid. Right, we all have heard the theory about the asteroid hitting the Earth. Now, I should also mention, out in space, it's called an asteroid. As it comes through the atmosphere, it's a meteor. On the ground, it's a meteorite. So technically, it's all the same thing. You just call it differently depending on where it is. Asteroid. Sometimes a meteoroid will break off of an asteroid, but generally, an asteroid in space, meteor as it's coming through the atmosphere, and then meteorite if you find it on the ground. Again, all the same thing, you call it differently depending on where it is. Similar to lava and magma, right? Magma is below ground, and then once it erupts and comes above ground, it is now lava. It's the same stuff. You just call it differently depending on where it is. So we all know. What? Go ahead, Christina.
Can we take a quick question break?
Yeah.
Anthony wanted to know how many species of dino were there before they went extinct?
How many species of dinos were there before they went extinct? A lot, and we're not exactly sure. While I answer this, I'm just going to share this picture again as a reminder that, you know, as we're doing our talking here, draw your ankylosaur. I'm excited to see these heavily armored walking tank dinosaur renditions. So we don't know how many dinosaur species there were, and we still don't, right? The fossil record is incredibly incomplete, and we're finding new species all the time. And so the amount of dinosaurs that we have currently found, maybe we found 90% of all dinosaur species. Maybe we found 9%. Like, we just don't know. So it's incredibly hard to know how many. If you ever want a fun 10 minutes on a Google search, just Google like exhaustive list of dinosaur names. You can find all the names, including ones that start with like X and Q and Z.
And in the chat, Ethan mentioned something called preservation bias. So
Great.
To your point, there's a great possibility that there are tons of species that we haven't found any fossils of, or there might be some that we found tons of fossils of, but those just happen to be preserved, so it looks like there were more of them than the other things.
Yeah.
I have 2 hands up. I had Mary Beth's hand up, and then Rob's. Do you have time for 2 questions, Dustin?
Hit it.
Okay, Mary Beth, go ahead. Oh, sorry. Let me try your button again.
We'll do these 2 questions, then we're going to get into exactly how we know an asteroid hit, as well as like what happened like in that moment and shortly thereafter. But go ahead, Christina. What do we got?
Go ahead, Mary Beth.
I still can't chat, and it's a disabled chat.
We can hear you, Mary. Hit it. What's your question?
That.
Oh, all right.
Okay,
so
I'm sorry, Mary Beth. I'll keep working on that.
All right, we're going to work on that. We want to make sure your Zoom capabilities don't go extinct. All right, Christina, what do you got?
Okay, Rob, what is your question? Go ahead.
So there's been we all know about the great debate of what caused the dinosaurs to go extinct, and I've always wondered what killed some of the more dinosaurs that could handle the extreme heat of whatever hit it.
Okay, yeah, that's a good segue. We're going to talk about that right now. So people recognize and we learn all about this asteroid that hit the Earth. So first of all, how do we know an asteroid hit the Earth about 65.5 million years ago? Well, in most parts of the world, if you go and look at the rock strata, layers of rock, and you date and you look at about 65.5 million years, there's literally in many parts of the world a line that you can see. You can see a line in the rock, and I'm going to bring up the image right now. And this line is called the KPG boundary, the Cretaceous Paleogene boundary. It's K because the C had already been used for Cambrian, so we can't use the C again. So KPG, it marks the boundary between, can you guys see these layers of rock? It marks literally the boundary between dinosaurs and no dinosaurs in the fossil record. And in some parts of the world, you can actually see that line really, really well, even more just than that line in the rock. Let me bring up this image right here. Here we go. Can you guys see this line in the rock?
Mm-hmm.
Yeah. So in lots of parts of the world, you can literally see that line. And that line many times is made up of a high concentration of iridium. Now, iridium is a mineral that is rare on Earth, but it's found in large concentrations of meteors and asteroids. So it's a pretty good indication of something giant slammed into the Earth, threw its guts up in the air. Those guts settled in the rock or in the ground all over the Earth, and now have left this line in the rock that you can literally see with an untrained eye. And below that line, you have dinosaur fossils, and we have never found even a single dinosaur fossil, outside of birds, we'll get to that in a minute, above that line. So that's literally a line in the rock at 65.5 million years ago, separating dinosaurs from no dinosaurs in the fossil record, right? And so before though, let me unshare for a second, before we even, well, that was seen for a long time. So it was postulated for a while that this was caused by an asteroid. And it wasn't until about 30 or 40 years ago that I think it's a father and son, it's called the Alvarez hypothesis, that a giant asteroid hit and caused this. And then it wasn't again until about 30 or 40 years ago that we actually found evidence of that meteor impact in what is now the Yucatan Peninsula in, well, the Gulf of Mexico. So from space, maybe the asteroid looked a little bit like this coming in. So that is basically, you're hitting just southwest of Florida. Let me show you a different one that's a little bit more zoomed in. So we have an exact idea. This one's pretty good. You can see kind of exactly where you see Florida up in that top right corner, and then the impact's up and right there on that kind of the hook of the Yucatan Peninsula in Mexico. If you want to zoom in even farther, this is probably what it looked like on the ground day of, right? This is a joke for boomers, I guess. No. This is kind of maybe what it looked like. Also, let me stop this for 1 second.
Do you guys have time for one more question or no?
We're gonna come back to it in a second, Rob. Can you mute for a minute though? We're gonna get through this last
we'll
part.
Come back to you.
Extinction. All right, so we know this thing hit the Yucatan Peninsula, threw a bunch of its guts up in the atmosphere. We now actually know where that crater is. Hit about 65.5 million years ago. So when a giant space rock, the size of the state of Delaware, moving, I wrote this down because I didn't want to mess this up. So it was the size of the state of Delaware. It was moving at 12 miles per second. That is 20 times faster than a speeding bullet. So something 20 times faster than a speeding bullet, the size of the state of Delaware, crashes into the Yucatan Peninsula right there. Anything anywhere nearby is going to be pretty much vaporized right away, right? But after that, I mean, you can imagine, like, if you took a ball, like a tennis ball, and you dropped it into water, you'd have, not only would it like make a dent down into the water, but you get a lot of splash back up, right? And you can imagine the same thing would happen with this asteroid. Slams into the ground, shoots a ton of its guts back up into the atmosphere, right? And so now you have literally billions of tiny pieces of meteor encircling the globe. And we think for a period of time, well, first, as those got pulled back down to Earth, after they got shot back up, pulled back down through gravity, each one of those heated up a little bit as it was pulled back through the atmosphere. Same way as the asteroid would heat up as it comes through our atmosphere. So you have the first impact, lots of heat warming up the atmosphere. Now you throw a bunch of your guts up in the air. Now you have even more heat when all of those are pulled back down to Earth. And now for who knows how long, your entire skies across the world are filled with dust and soot, blocking out the sun for a period of time. And then we probably have a chain reaction where no sun, plants have a hard time photosynthesizing, they start to die off. If there's less plants to eat, the herbivores start to die off. If there's less herbivores to eat, the carnivores start to die off. And we have a chain reaction that killed all non-avian dinosaurs and 75%. Now, we talked about the Permian extinction, 95%. This one killed about 75% of all animals on Earth, including all non-avian or non-flying dinosaurs, which we'll get to in 1 second, but I want to pause. Christina, I'm sure you've got a question or two.
Yeah, I have a few people's questions who have stacked up here. Jada asked how large Chicxulub crater is. It is about, from what I've looked up, 10,000 miles across, but it's underwater. Can't say for sure. Or not miles across, square miles. Almost 10,000 square miles. Let's see. Mike asked, usually after an extinction, the animals that survive are small. Can you share any examples of big species surviving?
Those are our two?
Yeah, let me go back through to make sure I haven't missed any others.
I hope everyone's doing great on their bingo cards. I feel like I've noticed that happen a couple times. I don't know where Max and the cats are. Yo, can I get a Maya cameo or what? So that's a really good question. Christina, actually, we talked a little bit about that last night. And so before we get into, before we even get into that, reminder that we are still working on our ankylosaur drawings. This is my brother's mock-up. He's a much better artist than me. Again, we're going to come back to those in a couple minutes, see who has the best ankylosaur. Christina, I know we talked about this a little bit yesterday. And so I'm curious to know, outside of what we're about to talk about, which are non-avian dinosaurs, why is it that we don't see large animals existing after mass extinctions?
This is a term that paleontologists love called the Lilliput effect.
Lilliput.
Yeah, it's from Gulliver's Travels, I think, where there's the island of all the tiny people.
Okay.
Right. So after a mass extinction event, the animals that are around afterward are usually much smaller than those that were around before. So either the small ones survive long enough to reproduce, or the new species that evolve after the event are much smaller. And that's probably because there are not a lot of resources to go around after a global biotic disaster.
That's a great segue, and it speaks to exactly why I believe birds were able to survive. So some mammals survived as well. There were some small, basically like shrew, mouse-like mammals that survived, thank God, because if they had not, we wouldn't be here. But when we say dinosaurs went extinct 65.5 million years ago, again, we are talking about non-avian, non-flying dinosaurs, because we have birds today, and birds are literally dinosaurs. We're going to talk about what I mean by that tomorrow. But how and why did birds survive when all the other dinos didn't? There's a few different theories. My guess is, well, there's three parts. So first of all, birds are small, right? You don't need a ton of food. You don't need a lot of calories to survive. versus like a brachiosaurus, which literally needs a crap ton of food every day, right? So much food. T-Rex, brachiosaurus, big guys, hard to survive when there's less food around. So birds are small, that's one. Number two, they're opportunistic omnivore. Oh, I can never say that. Opportunistic omnivores, usually, most of the time, which means they will eat whatever they can, whenever they can, wherever they can get it, whether it's food or whether it's insects, whether it's plants, whether it's meat. Birds will eat a wide variety of things, whereas like a T-Rex is not going to eat plants, Brachiosaurus is not going to eat meat. So they were small, they could eat whatever they wanted, and they could travel distance easily, right? If there's not a lot of food around and you can travel easily to find it, that's probably going to help you survive. So those are the three reasons I think birds were able to survive this mass extinction. Small, can eat anything, can travel to find it. And we're going to talk about exactly why birds are dinosaurs tomorrow, how we know that, why we think that, and why that is freaking amazingly cool. Any last questions, Christina, about extinction?
Yeah, I had one from Suram who said, we have an observation that the KT boundary is like a gift wrapper all around dinosaur fossils. How was life before and after? And I asked the clarifying question. So what Suram means is, what were the conditions on Earth like before and after the impact?
Good question. Not really sure. I mean, after the impact, probably warmer and more noxious. The gas had more noxious or like very bad chemicals in it from all the volcanic activity and from the asteroid spewing its guts up into the air. So it's probably hotter initially and then colder when that started to block out the sun. But the conditions before it were not so dissimilar from today. I mean, the oxygen levels were a little bit different. It may have been warmer or colder in certain parts of the world. But yeah, we're not really sure exactly what happened or what it looked like immediately after. And Christina, we talked about this last night. After each mass extinctions are different in that sometimes the Earth gets much colder and things can't live. Sometimes it turns into much more like desert environments. So it really depends on that particular extinction. We still aren't really sure about this one. Is that fair, Christina?
Yeah, absolutely. And that ties into a question I was just seeing from Jeff asking about if Ice Age is no longer dinosaur extinction theory. And I was hoping to explain that there have been several ice ages in Earth's history, and some of them have gone along with mass extinction events, and others have had much hotter conditions. Yeah, so like you said, it comes with a variety of changes in conditions.
Cool. All right, you guys, we're getting towards the end of our time together today. Like I just mentioned, tomorrow, I'm very excited because we're going to talk about birds being dinosaurs. Hashtag birds are dinosaurs for sure. So tomorrow we're going to dive into like why we think that, how we know that, how they survive. So any questions you have about birds or birds surviving the mass extinction, or how we know birds are dinosaurs, how we know some dinosaurs had feathers, anything within that realm, drop those comments, drop those questions. We're going to use those tomorrow as we talk about birds being dinosaurs. I want to do a quick recap of today. So we started by talking about extinction. So extinction means there's no more of an animal anywhere. A mass extinction means lots and lots of animals went extinct together at the same time. The Permian is the biggest mass extinction the Earth has experienced. About 95% of all animals went extinct. The KPG extinction, the one that killed the dinosaurs, non-avian dinosaurs, that was about 75% of animals on Earth, so not quite as bad. Oh, I should also mention, that also spelled the end of pterosaurs, flying reptiles, and a lot of marine reptiles as well. So we think about things that lived at the time of the dinosaurs, like mosasaurs, plesiosaurs, certain pterosaurs, flying reptiles. Yeah, they got the ixnay at about 65.5 million years ago as well. We talked a little bit about how birds or how things in general might survive an extinction, as well as exactly, well, what we think may have happened the moment of impact and shortly thereafter. But a lot of it's still up in the air, right? So it's a lot of different variables that cause this extinction. Climates are changing, sea levels are rising. There's a lot of volcanic activity all over the world. And so if the asteroid in of itself, by itself, wasn't the thing that killed it, it was definitely like the death blow. Some people think dinosaurs may have been kind of on their way out when this extinction, when the asteroid hit. Hard to know, but at the end of the day, like if we got to put our finger on one reason, I'm going asteroid. So Christina, do we have any last questions before we jump in, or I'm sorry, before we say bye to our friends? Oh, Oh, wait. We forgot about our drawings. I need to see some of these ankylosaurs. I know we have some very intrepid artists. I'm going to see. Oh, that's a really good Cecilia ceratops. That's a great ankylosaur. I like that. Wow, I like how thick that tail is, too. It looks like it has a very friendly face, too. It's a really good one. Do we have any other ankylosaurs? Hold them up. Joe. Oh, I like that. Lots of spikes. The face kind of looks like Kermit. I'm into that. Jadal. Oh, nice. Oh, wow. Wow, that is like I feel like that should just jump out of a Disney movie right now. I love that ankylosaur. Very well done. Let's see Margot's. All right, Margot, are you a professional artist? What's this? What are you doing? Come on. That is so good. Some great ankylosaurs. Oh, Ethan, let's see. We did some head studies of some different ones, including the ankylosaurus. I like that. Oh, we got Triceratops, and Natotitan, ankylosaur. Wow. We have some very artists.
Ankylosaur is playing soccer by Denise.
Are you wearing a Man U? Is that a Man U hoodie? No, I can't. Put your arm down so I can. Ethan, what is this? I can't see. Oh, it looks like a Manchester United hoodie. That's okay. All right, we got Jess CR. Jess, you guys are phenomenal artists. These are so much better than anything I would have drawn. Are you kidding me, Sharam? Sharam, that is great. You even look, he labeled the parts. We got a beak, we got a tail club, we got the osteoderms. Osteoderm is O-S-T-E-O. Osteo means bone, derm, D-E-R-M, which means skin, like bone in skin. Osteoderms look great, Sharam. Thank you for that. Ooh, Franis. All right, you guys. Is this art school? Who are you? How do you guys draw this well? These are amazing. If I had half this artistic talent, Emerson, let's see what you got. Oh, I like that you have an audio hint here too. There, Emerson, we know kind of, oh, and we got the meteor incoming. Watch out. Watch out for the incoming meteor. M, did you just do that? Did you just draw that? All right. Well, something I'm learning today is that you guys are phenomenal artists. That is amazing. Please post these anywhere and tag me. I'll share them. They're amazing. All right. We got one from Bryn. Bryn, I love the repeating pattern of the osteoderms, the ankylosaur back here. I should also say, some people say ankylosaur. Some say ankylosaurus. Ankylosaur. It's up to you. Let's see how many more drawings we got. Oh, Joan Park. That's a really cute one. I'm into it. For some reason, the eye reminds me of anime a little bit. I'm into that one. Let's see, John and Ben. Wow, that is a Dick Tail Club. I want to stay away from that. That looks great. Alicia Junk, also a phenomenal artist. I love that you guys got the legs straight under the body. We learned yesterday a dinosaur has to have its legs straight under it. If it's splayed out to the side, that is a reptile, maybe related, but not a dino. Alicia Drunk. Oh, that is great too. That looks real good. You guys. All right. I think that is all of the amazing drawings. Oh, these are great. Do you have a favorite out there, Christina? I mean, these are very hard to choose from. It's very hard.
Oh man. I wanted to give a shout out to Where They Go. Also, Ethan, I see you with your hand up. I'll get to your question. Where did they go? Your name started with an F. Fraueins. I'm so sorry to say your name so poorly. But I want to give a shout out to your ankylosaur.
It's a good ankylosaur. I'm going to share the one my brother did one more time. I gave him like 3 minutes to mock up one, and he's a really good artist. You can follow him on Instagram, Max_tattoos. This is the beginning of his ankylosaur. But you guys, honestly, don't tell Max, but I think yours might be better. Oh, well. All right. We have 2 or 3 more minutes, Christina, which means let's finish with 2 or 3 questions, because questions are the bread and butter of science. You got to ask questions. That's why
awesome.
we're stay
Okay.
tuned.
We had a question from Araxi. I saw with their hand up. I'm about to unmute you. Go ahead.
I wasn't able to start the ankylosaur drawing.
Oh, you weren't able to start?
No.
It's okay. There's plenty of time. There's many hours in the day for more.
For sure.
So many hours.
Okay. I had Ethan with his hand up for a little while. Ethan, are you ready? You are unmuted.
G'day guys, how you doing? Now, so I'm pretty sure Dustin, you said something about there's no non-avian dinosaurs over the iridium layer. How do you explain the Ojo Alamo formation, where you have some examples of Tyrannosaur teeth and some other scattered bones, barely just over that iridium layer and sort of jiving in the tertiary or Paleogene?
Where is that? I missed the beginning. Where is that happening?
Yeah, I think it's the Ojo Alamo formation. So I think it's either in Texas or New Mexico somewhere. Okay. I'm not from the States, obviously. I'm Australian, so I'm not particularly familiar with the geography, but it's it's a pretty peculiar little site.
Yeah, where in Australia, by the way?
I'm from a little town called Orange. It's about 3 hours away from Sydney.
Okay, cool. I've spent a lot of time in Australia. Love me some Australia. You guys have amazing birds. That was the biggest takeaway when I traveled to Australia. It's just like there are crazy birds all over the place all the time. I have not heard about that spot. We all have blind spots with respect to the knowledge we have. I'm going to look into that. My first guess, I'll ask Christine in a minute, but my first guess would be some sort of geologic activity has jumbled rocks and moved them around slightly. That'd be my first guess. But if it hasn't, then yeah, that'd be a crazy first example of dinosaurs or evidence of dinosaurs after that extinction. Christina, do you know about this? What's the deal?
I'm not familiar with this formation, but I mean, I think you're on the right track. So I think if you find something that's totally out of place, like a dino up way more recently than it should be, the most likely explanation is that there has been something geological that's moved it around. So either, so I want to learn about this formation now, but there's probably been some sort of uplift or overturning or maybe something alive burrowed there. I don't know. There are a lot of possibilities that could take something from lower and move it up.
For sure.
That's a great question. And I like it because it speaks to the nature of data collection in general. Like we have this hypothesis, we have this great evidence of that line. And if we found one example of something that potentially disproves it, I think we need to try to find a lot more before we really amended or, went back and changed what we thought. So that's a great question. I'm going to look into that. Thank you for bringing that up. A couple of questions from Instagram. I just want to let you guys know, if you want to see these pictures, you got to be in the Zoom room. Also, Ethan, quick question. This is coming from Instagram. Is the KPG boundary in Australia upside down? Christina, I think we did it. I think our time is just about up. Do you have any final words, inputs, extinction jokes?
Oh man. No, but I did see a lot of questions about dinosaurs with feathers in the chat. So it sounds like people are already excited for tomorrow.
We're going to kick so much dino butt tomorrow. So much dino butt. We're going to talk about feathers, we're talking about birds, why birds are dinosaurs. But unfortunately, our time together today has gone extinct. No? All right. You guys, thank you for coming. We'll see you again tomorrow. Same bat time, same bat channel. And remember, I don't care whether you are studying or you're a professional backhoe operator. Never stop digging. See you guys tomorrow. Birds or dinosaurs? Let's go! Okay, I have to come back and end the meeting now.
Bye everybody.
Bye, everybody. See you tomorrow.